My science fair project was experimenting with natural and synthetic fabric strength. Dyeing fabric has been carried out for centuries. During ancient times, people would commonly dye their fabrics using materials that could be found in nature, such as animals and plants. Today, however, chemicals are widely used to dye fabrics. The most common synthetic dyes are acid dyes. Acid dyes are water-soluble anionic dyes that are best absorbed by protein-based fibers such as silk, nylon, and wool. Like dyes, fabrics have also evolved. At the beginning, only natural fabrics were used, such as cotton, linen, and wool. Now, however, many other fabrics have been created synthetically, like nylon, rayon, and polyester. Through the evolution of the fashion industry, new products have been generated, possibly altering the quality and strength of common items. In order to test the strength of certain materials, a series of trials must be completed. An example of these tests is tensile testing. A tensile test or tension test measures the strength of materials by pulling at them and applying weight to them until they break. The purpose of this experiment is to see whether or not natural and synthetic dyes have an effect on the strength of different types of natural and synthetic fabrics. In our everyday lives, we buy clothing and products that have been dyed and processed. These products are sometimes not of a very high quality, which tend to cause the fabric to tear or wear out easily. This experiment is designed to see whether or not the dyeing of fabrics has an effect on the strength of the fabric. The hypothesis was that the synthetic dye would make both the natural and synthetic fabrics weaker, causing them to rip easier than the naturally dyed synthetic and natural fabrics. For the procedure, the synthetic fabrics that were used were nylon, rayon, and polyester. The natural fabrics that were used were wool, cotton, and linen. Each fabric was cut into 3 6x2-inch pieces. The first piece of each fabric was stained with synthetic dye, and in this case red acid dye was used. And the second piece of each fabric was dyed with natural dye. In this case, ground coffee was used. And the third piece of each fabric wasn't dyed or manipulated in any way and served as the controls. In order to test the strength of each fabric, a hook scale was used. Hanging from the hook scale was a clamp from which each piece of fabric was hung, and at the bottom of each fabric another clamp was placed. From the clamp, S-hooks were placed, and from each S-hook, weights were hung until the fabric eventually ripped. The weights that were used were 2-pound weights, and washers were used to measure grams so that the measurements were more precise. This flat washer weighed 17 grams. This lock washer weighs 47 grams, and this hex nut weighs 52 grams. After measuring the strength of each fabric, the results were the control nylon ripped at 16 pounds, 260 grams, which equals a total of 7,517.472 grams. The synthetically dyed nylon ripped at 16 pounds, 152 grams, which equals a total of 7,409.472 grams. The naturally dyed nylon ripped at 16 pounds, 152 grams, which equals a total of 7,443.472 grams. The control polyester ripped at 17 pounds, 199 grams, which equals a total of 7,910.064 grams. The synthetically dyed polyester ripped at 18 pounds, 25 grams, which equals a total of 8,189.656 grams. The naturally dyed polyester ripped at 17 pounds and 226 grams, which equals a total of 7,937.064 grams. The control rayon ripped at 14 pounds, 116 grams, which equals a total of 6,466.288 grams. The synthetically dyed rayon ripped at 15 pounds 94 grams, which equals a total of 6,897.88 grams. The naturally dyed rayon ripped at 14 pounds 99 grams, which equals a total of 6,449.288 grams. The control cotton ripped at 12 pounds 82 grams, which equals a total of 5,225.104 grams. The synthetically dyed cotton ripped at 12 pounds 176 grams, which equals a total of 5,619.104 grams. The naturally dyed cotton ripped at 12 pounds 64 grams, which equals a total of 5,504.104 grams. The control linen ripped at 20 pounds 181 grams, which equals a total of 9,252.84 grams. The synthetically dyed linen ripped at 19 pounds 262 grams, which equals a total of 8,880.248 grams. The naturally dyed linen ripped at 19 pounds 245 grams, which equals a total of 8,863.248 grams. The control wool ripped at 22 pounds 35 grams, which equals a total of 10,014.024 grams. The synthetically dyed wool ripped at 21 pounds and 215 grams, which equals a total of 9,740.432 grams. The naturally dyed wool ripped at 21 pounds 232 grams, which equals a total of 9,757.432 grams. The total weight that caused the control fabrics to rip was 46,686.008 grams. The total weight that caused the synthetically dyed fabrics to rip was 46,736.792 grams. The total weight that caused the naturally dyed fabrics to rip was 45,957.608 grams. The total number of weight that caused the synthetic fabrics to rip was 66,220.565 grams. The total weight that caused the natural fabrics to rip was 73,159.536 grams. When determining the weight for each set of data, the weight for each clamp and each S-hook was kept in mind. Each clamp weighs 20 grams and each S-hook weighs 5 grams, in addition to the 2-pound weights and each washer that was added to the fabric when measuring its strength. These graphs show the comparison between each set of data. This graph shows a comparison of grams at which each set of dyed and control fabrics ripped. The synthetically dyed fabrics can be seen as the strongest set in this graph, since they ripped at 46,736 grams. And the naturally dyed fabrics were the weakest, ripping at 45,957 grams. This graph shows the comparison of the grams at which each of the synthetically dyed fabrics ripped. The strongest fabric can be seen as wool, which ripped at 21 pounds, 215 grams, or 9,740.432 grams. The weakest of the synthetically dyed fabrics was cotton, which ripped at 5,619.104 grams. This graph shows the comparison of the grams at which each of the control fabrics ripped. So the strongest control fabric was also wool, which ripped at 10,014.024 grams. The weakest control fabric was also cotton, which ripped at 5,525.104 grams. This graph shows the comparison of grams at which each of the naturally dyed fabrics ripped. Again, the wool can be seen as the strongest fabric, ripping at 9,757.432 grams. The naturally dyed cotton was once again the weakest fabric, ripping at 5,507.104 grams. This graph shows the comparison of grams at which each synthetic fabric ripped. Of the synthetic fabrics, polyester was the strongest, ripping at a total of 25,000 grams. This graph shows the comparison of the grams at which each natural fabric ripped. Of the natural fabrics, wool was the strongest, ripping at a total of 30,000 grams. This graph shows the comparison of the grams at which the synthetic and natural fabrics ripped. The natural fabrics can be seen as the strongest, ripping at a total of 73,159.536 grams, while the synthetic fabrics ripped at a total of 66,220.556 grams. After comparing all of these sets of data, it can be concluded that the strongest fabric in the set was the piece of wool that was not dyed, which ripped at a total of 10,014.024 grams. The weakest fabric was the synthetically dyed cotton, which ripped at a total of 5,507.104 grams. The synthetically dyed fabrics were the strongest compared to the control and naturally dyed fabrics. The synthetically dyed fabrics were 50.784 grams stronger than the control fabrics and 779.184 grams stronger than the naturally dyed fabrics. Overall, the natural fabrics were stronger than the synthetic fabrics. The natural fabrics were 6,938.88 grams stronger than the synthetic fabrics. The hypothesis was partially supported. The synthetically dyed piece of nylon was the only fabric of the set that was weaker than its control and naturally dyed counterparts. In conclusion, the acid dyes did not affect the fibers of the fabrics in any way other than their pigmentation. The acid dye did not have a significant effect on any of the fabric's strength. This is the reason why synthetically dyed nylon was the only fabric that was weaker than the naturally dyed and the control nylon. Even so, the synthetically dyed nylon was not significantly weaker than its counterparts. The synthetically dyed nylon was only 108 grams weaker than the control nylon and only 34 grams weaker than the naturally dyed nylon. Although the dyes did not have an extreme effect on the strength of each of the fabrics, a moderate difference in strength could be seen when comparing each of the fabrics to each other. In the future, if this experiment could have been repeated, more trials could have been executed in order to have more data to analyze. The ratio of water to the natural and synthetic dyes could have been varied to see if the concentrations of the dyes affected the strength of each fabric. Also, a stopwatch could have been used to time the rate at which the fabrics ripped in order to achieve more accuracy. Finally, different synthetic dyes could have been used other than acid dye. If you have any questions, please feel free to ask. Thank you for your time.